your National Museum of American History, and I'm delighted to welcome all of you here today for a very special event. And we're going to be adding a number of objects to our collection representing the development of autonomous mobile robots to the National Collection here at the American History Museum. And we're standing in one of the centers and one of the facilities operated by the Lemelson Center, Spark Lab. Across the corridor from us is another gallery where an exhibition called Invention at Play is located. And if you come here on a normal day, and I'm not sure if Cherry Blossom Week is a normal week here at the museum because we have thousands of people from around the country and around the world who are here, but you'll see what a great activity center this is, this both Spark Lab and the Invention at Play exhibition. And I think this particular gathering, we've increased the average age by about 20 years, or 25 or 30, 40 years. But normally we see children and parents learning and experiencing the history of science and the history of technology in Spark Lab, and then also at Invention at Play. And it's really a terrific, terrific part of the museum program.
It's wonderful to kick off National Robotics Week here at Spark Lab. This is a place dedicated to the history of invention, but also to inspiring young people. This is one of our most dynamic spaces in the museum, and I guess it's been one of the great surprises that there's this well of interest in invention among our young people. Coming in with their parents and other adults, this interaction, as Brent said, has been really wonderful for us to see. I think it's really fitting that we're looking at robotics as a critical technology for Spark Lab.
A few words about the museum's robot collection. Collection here is small, fewer than 100 things. Our collection is significant because it contains representative pieces of key strands in the web of robot history. What's more, the collection is beginning to grow in new and really intriguing directions, just like the field of robotics itself. In choosing the objects that we bring in, not just to the robotics collection, but to all our collections, we take the long and the wide view to answer the question, what is a robot?
I'm up here not just for myself, but really on behalf of my brother Dave Hall, who is the inventor of all these items. He single-handedly conceived and pretty much single-handedly built all the things you see here today. He really is one of the great inventors of our time. I don't say that just because he's my brother, but I've worked with a lot of people. Dave really does have the engineering strength of 10 men. If we look back to the history of these items, Dave actually conceived and founded our company, which is Velodyne Acoustics. We're a small privately held company in Morgan Hill, California, which is about 20 miles south of San Jose. In 1983, and he worked the audio business, creating a servo system for loudspeakers, which made subwoofers sound much better. And any of you into audio and might know high-end audio, you might know Velodyne. Made a name for ourselves in that business. In the 90s into the late 90s, there is a theme that ties these things together, and it began in the late 90s, and it was getting on TV. And Dave saw the opportunity through fighting robots to develop a new walking mechanism, which you can see in the claw that we developed, which gives the unit a 1.5 times weight advantage, which is a good thing if you're trying to go into an arena trying to fight other robots and trying to push them around. So this is an example of Dave's analysis of a situation and realizing how much better the technology can be and going about to create that leaps and bounds movement ahead in the technology.
So this was a project so small in not just size but in scope, we never thought it'd go anywhere. It was just a project to see how small we could build a robot, and we learned some things. We ended up scrounging parts from toy locomotives for this and from pagers, places like that. We had to get parts from somewhere. We learned, for one thing, that it has terrible mobility, doesn't go much of anywhere. Terrible battery life. Power and mobility turned out to be the problems in small robots. The later one you saw, climbing over nickels and dimes, that was a way of addressing that. They put tracks on it, they had a much more efficient motor system, much more efficient motor drive. It made a big difference. It increased mobility greatly. I always said this did what it was made to. It found money. It found projects for us. It started a whole new realm of robots at Sandia. We built probably half a dozen different generations of robots based on what we learned at Mars. We learned a great deal doing this. Before we had done this, we'd never done anything small. It was completely new to us. In the mobility area, mobility and power, that's where the hoppers came from. And as Carlene mentioned, that we ended up in the Guinness Book of World Records in 2005. They put us down for a 30-foot hop. It was really more like 50 feet. We had intended every year to add 5 feet to it so we could get into the yearbook year after year. We never did that. You'll see a couple of those back there. In fact, one of them, the round one, is a swarm robot, just like the NetBots and just like the small plume tracing robots. It was also a swarm. We did a lot of work with swarm behavior at that time. And it's it's an honor to be here and a real surprise that something this such a small project would end up in Smithsonian. Thank you.
This acoustic cone so that they chirp and they send acoustics in time all up. It's reflection come back there from mapping outside buildings.
Yeah, the guy that did the radio on this one is the guy who did Sir.
Oh, I see.
Yeah, John Harrington.
A
So
wizard of radio.
he's our radio guy.
Barry, where's the jumping? Which is the jumping?
These two guys. This is an earlier version. Well, this piston,
That's the piston.
this is what makes it jump. This puts out about 1,000 pounds of force when it fires.
That is about half.
What you need to make the thing go high enough in the short stroke you got.
The next step from there is
This was made for jumping in really soft ground. That's why it's got
available to cars
a
everywhere.
really big foot on it. This whole foot goes down. There's a piston inside here.
This type of sensing technology we believe on every
It's much more interesting than the top line.
So the idea is that Robbie's going to be able to manipulate the same kinds of tools and objects that people do, and we'll be able to do that in an autonomous fashion. So I could say something like, go get that screwdriver, and Robbie will be able to go ahead and go do it. If you think about the example of an operating room where there's a scrub nurse or a scrub tech, the person that goes and finds the tools and puts them in the hands of the surgeon, Robbie, once the program is over and successful, will be able to do tasks like that. Now, we're not going to use Robbie in an operating room, but there's plenty of situations in the military where we really do want an assistant or partner that plays that same kind of role, just like a scrub tech does for a surgeon. So you can say, go get me that whatever, and Robbie will be able to go do it.
So it's like really long thing. I remember having trouble at the museum with somebody with big hands, like. But yeah, stick hands over close too much.
I had that covered up.
That's a pretty good time for you for color.
What it does is it's a social media robot, which means that it interacts with the human who's in a disaster. It's meant to be placed on a mobile robot that can bring it into a disaster and interact with the human and to comfort them, and can also bring them information from the outside world using its screen, and people can see them using the camera so that doctors and other trained professionals can get a look at them and interact in a way that's comforting and easy to use. There's a lot of studies that show that robots are inherently scary to humans. So what we're doing is we're working on those studies and showing what aspects of the robot are more comforting than others and how we can enhance those. And so we're using that work, and the computers are social actors framework that Dr. Cliff Mass at Stanford has established to further improve methods of interacting with victims.